Okay, so let's have a look here. So we're just going to zip through all these problems that are on the test, in the practice test. Remember, practice tests are worth nothing in terms of a grade, but they're there as a resource. I think a lot of times the way people most successfully used the practice test last year was not necessarily to always just go through from start to finish, although you can. A lot of times people used them, I think, just to go through and say, okay, I can do that, I can do that, I can do that. Here's what I need some practice on. And then you can just keep reloading it to get as much practice as you need, okay? So how about this? Does the graph represent a function? No, it doesn't. And why is this? Okay, fails the vertical line test. There is at least one place where a vertical line intersects the graph in more than one place at a time, right? So fails. How about that guy?
Fails.
Same thing. That is a vertical line, and so they overlap at an infinite number of places, so it fails. How about that? It fails. It's good every place over here, except there's one spot there where 2 points line up vertically, so it fails. Okay? Good. Okay. Okay, what about this? This is probably one of the most, I think, despite the fact that this is really a pretty easy problem, people had a hard time interpreting what was being asked. The important part of this, as far as the reason I wrote this problem and included it, almost has nothing to do with perimeter. That part's, I mean, a little geometry review. But this is the part that I wanted you to focus on. Writing something with function notation. A really simple relationship. That part's not hard. It's the writing it in function notation part is the part that I'm concerned about. So let's start with a rectangle and tell me where to go with this. So we want to come up with an expression for perimeter. We're going to write it using function notation. The perimeter of this rectangle. How can I label the rectangle? What goes where? Got a couple choices.
With this one.
Okay, so let's say that's 11,
X.
that's X, and we could flip-flop, it doesn't matter. How do we calculate a perimeter?
Like times width.
No, that's area.
Add all sides.
Add all sides up. Okay, so if it's a rectangle, we can take a little bit of a shortcut with that. What do we do with the rectangle? What do you think? What's our, and if you don't remember it, you can always just derive this formula. What do you think? 2 times width plus 2 times length, something like that. I mean, or you can just add them up, but ultimately when you simplify it, you're going to get the same answer, right? So the part we're interested in is, I'm going to write this as an equation. P equals 2 times X plus 2 times 11, which we can just simplify to a 22. But the important part is this. Okay? How come? What's that telling us? It's not P times X. How would we say that?
P of X.
P of X, or P is a function of X, right? So this is telling us here that we're using function notation. We're inputting values of X so we can calculate and get back values of perimeter. Okay, so this is how the answer should be entered. Okay, that's the part I want you to understand. When I say function notation, I mean like this, okay? Where it's telling you specifically what are you inputting and what are you outputting.
So you don't technically have to solve it, you just put it in?
Well, I mean, you have to, you do have to get this part, but that part's not really, that's just secondary. That's just there as some kind of an excuse for giving you a function notation problem. Okay, does that make sense?
Yeah.
I mean, you have to get it right, but the perimeter stuff is not a big deal. I mean, that's just, yeah, it's a little bit of geometry review, but you guys all know this. Yeah, I might have to think about it for a second. This is the part I'm mostly concerned about, right? Okay, you will get one, similar to this on the test. Okay, how about that? Evaluate the polynomial when x equals 2. So what are we doing? When we evaluate, what are we doing?
Plug it in.
Plug it in.
Right.
Yeah,
Put it into
value means number, right? And so we're just plugging in the value 2 for x. Now, how can you do that? You can almost think about this, and this sounds a little hokey, but this is a good way to think about it. F of x follows this pattern. F of whatever the input is. Just open up a set of parentheses, and we'll fill in the blank later. Equals the input cubed plus 7 times the input squared plus 6 times the input plus 5, right? So whatever we're putting into our input, it's going to get reflected into the rule in all those places. I think it's really a good idea when you actually get down to the nuts and bolts of evaluating a function and you're putting stuff into a calculator, for example, use parentheses. Parentheses helps. It helps you remember what the rule is. If you have negative coefficients out front, it helps you remember that I'm going to do the exponent first and then make it negative, right? See what I'm saying? If you're putting in a negative value, it helps you remember that I have to put the negative in parentheses when I take it to a power. If it's a fraction, if you put it in parentheses, the calculator just sees that as a number. No big deal, right? So always put the values you're inputting, put them in parentheses. So if I'm inputting a 2, I just get that, right? And then I simplify it. So what is 2 cubed?
8.
Good. 8 plus, what's this going to do?
4.
4 times 7,
Oh,
28, good. Plus
12.
plus 5. So 12, and these are convenient. 28 and 12 is, 48 plus-
53.
there you go, 53. Okay. How about that? So these will be pull downs. Excuse me.
Oh, I know these.
So you're going to be able to choose from a set of options. Like the first one's going to give you, just a bunch of different choices. So what's going to be the correct way to write the domain using set notation? So your
11.
choices are going to be inside the set brackets or the script brackets.
11, 12.
11, 12. So how come? Well, we don't have to write repeated values in the domain. We wouldn't write like 11, comma 11. That doesn't make sense because 11 is one of the parts of the domain. We don't need, it's, sure it shows up twice, but big deal. It's still just 11. You want to write them in numerical order also. Okay, what about the range?
8 and 11.
Okay. Is it a function?
No,
It's not. How come?
because there's the same numbers.
Same number.
Yeah, okay, you get repeated values in the input, which means we don't care about the output part, right? You can have repeated values in the output, but if you have repeated values in the input column in a table, think what that's saying. That's saying that we're having, like, for example, if I input 11, I could get back 8, or I could get back 11, right? If we were to write this using like a Venn diagram, where this is our domain, and that's our range, that means that the single value 11 is going to map to both an output of 8 and an output of 11. And now we can see there's 2 arrows coming from that 11. So it's not a function, right? Yes?
So what if it said like input 11, output 8, and then the other 11 said,
Said 8.
yeah,
Oh, then you'd be fine.
okay,
That'd be really tricky. I did give you one like that, didn't I?
I think so.
I think there's one on there. That's pretty tricky. But so it shows up twice in there, but in both cases, it's just a single output,
Yeah.
right? Okay, so that would have been okay. Yeah. But I won't, I was trying to make a point with that question, but I wouldn't put it on a test because it's really kind of a, I mean,
Yeah,
why would you write
I think
the
I got it
11?
wrong because I just was skimming through because they were easy and I
Right.
just like, oh. this
Well, and I was
is
kind of
what-
trying to, and so you can probably see why I put it on there, but I don't really like it that much. I wouldn't put it on the test. Okay, how about that one? Domain, using interval notation. So domain is the set of what now?
X.
X values or input values, good. Okay, so what are all the X values here? Is there any limit to the X values? No, it's not. You gotta remember this, there are no endpoints shown here, right? So this function goes forever. So an ant could walk forever to the left. And as he does that, he's gonna go down forever, but big deal. There's nothing to stop him from continuing on to the left and down, right? Same thing, opposite direction, you could go to the right and up forever. So the domain is unrestricted, so it's all real numbers. How do we say all real numbers or unrestricted using, let's do it first using an inequality. X is what? How do I say that? All real numbers, no restrictions.
Infinity.
X is greater than negative infinity, so all negatives, and less than
Positive infinity.
positive. So it's every number between negative infinity and positive infinity, which is every number, right? Okay, make sense? So it's kind of a weird way of saying it, but that's our inequality way of saying unrestricted or no real numbers, okay? And then remember, how did we write that using interval notation? What are the numbers then? Well, right? What kind of symbols on the outside? Those guys, right? Because we can't include the endpoints because there are no endpoints, right? Does that make sense? If you put square brackets would mean we're including those endpoints, but you can never get to infinity. It's not a number, right? So they have to be rounded. Okay, while we're at it on this one, let's just write down what would the range be. So if we write it as an inequality, we have to use a y, don't we, right? What's it going to be? Is there any restrictions on the range? Same thing then, isn't it? Y is greater than negative infinity and less than infinity, right? And if we write it using interval notation, it looks just like the domain because they're both unrestricted. Okay? Questions? You good with that? Okay? How about this? Different. Let's look at the domain this time. This time there is a definite domain, right? So what do you think? Wyatt, is there a bottom x value for this function? Is there a place, in other words, we're talking about domain, we're talking about x values, so we're looking horizontally only. You're just asking yourself, what's the furthest to the left and the furthest to the right that an ant could go?
-2 and
2. But we're looking only horizontally now. So the furthest left he could go is what?
2.
Is to 2.
Oh,
Right.
okay.
See what I'm saying? We don't care about the vertical part of this, right? So he's going to walk to the left until he gets to that point. Well, that's an x value of 2. So when we want to graph the domain on the x-axis, we're just going to plot that set of values on a number line, essentially, right? So x has to be greater than or equal to 2. What's his top value? Highest x value we could have. 10. Right? And so there is a graph of the domain. Right? Everybody see that? What did we really do? If this helps, great. If it doesn't, you don't need to use this. But one way I kind of think about that is if I took the function and I just squashed it vertically onto the x-axis, wouldn't it make that stain on the x-axis? Right? The endpoints would be solid because I had solid endpoints there, and all the places in between would get filled in, right? That's one way to kind of think about it. Or think about a shadow. If you're casting a shadow from below and above, where's the shadow going to be on the x-axis? Well, it's going to be there. Now, if that had been an open circle, that would have been an open circle too, right? Everybody see that? If that were open, that would be open.
What does open circle mean again?
Not including the endpoint, right?
So it doesn't have a line underneath.
So, right, exactly. So then that would have been, if that were open, then the ant couldn't step on 2, but he could step on all values greater than 2 and less than or equal to 10. See what I'm saying?
Yeah.
Okay? All right, so how would I write that then? Using an inequality, it would just look like x is greater than or equal to 2, agreed, and less than or equal to 10. Using interval notation, what kind of symbols am I going to use on the outside?
Bracket.
Brackets, okay?
Wait, why? Because that's as far as you can go, right?
Right. And we use brackets. Remember when we say, so here's the statement, I think this really helps. So you understand what inclusive versus exclusive means, right? Inclusive means containing, exclusive means not containing. So this is an example, let me just show you something here. So this is an example of, oh, it's white, you can't see that. Didn't show very well, did it? So that's an example of an inclusive endpoint, right? It includes the endpoint. An open circle means exclusive, right? And what we always remember about this is inclusive takes more ink, right? Takes more ink because I have to fill in the dot, I have to write the equal sign under the inequality, and I have to draw a bigger square bracket instead of a rounded one, right? So inclusive endpoints always require more ink to represent, okay? All right, moving on. About the range.
Oh, I don't know what that is.
Okay, so now range is, what does range mean? It's a set of all, what, domains and ranges are just sets of values, set of the y values, or the outputs, right? So when we want to find the range, we're going to take everything and squeeze it onto the y-axis. So then what's going to be the lowest point on the range? What's the lowest value, smallest y value, okay, that an ant could stand on? It'd be right there, wouldn't it? If I squeeze this thing over, like for example, that point right there is going to stay in the y-axis right there, isn't it, when I squeeze it together? Okay, what's the biggest point?
Positive 6.
Positive 6, that point right there. Going to make a stain right there. Or it's going to cast a shadow if we're using a flashlight, right? And then everything in between is fair game. An ant could walk on any y value in between those extremes, right? So there's my range right there. Now let's write it as an inequality. Well, what's that going to look like? Y is what? Kind of turned sideways here. Y is what? That's a negative 6.
It's greater than
Greater
negative
than-
6, but less than positive 6.
Okay, greater than
Or equal.
or equal to
Yeah.
negative 6 and less than or
Or
equal
equal
to
to
positive 6, right? Written as an inequality, and that's what we want. We want an inequality. Now, if we wrote that using interval notation, it would just look like that, right? Okay? Okay, how about that? Let's do two things on this, because I want to make a point. Let's do both the domain and the range. Let's do the domain first.
4.
Okay, so if I do the domain,
2 is greater than or less than x.
okay, so that's going to be, if I were to squeeze this down onto the x-axis, right, what are the x values that an ant could actually walk on? 2, including 2?
Yeah.
Yes? Okay, up to,
4.
do I include 4?
3.9.
No, okay, so I gotta do that, don't I, right? So if I wanna write the domain then as an inequality, it's gonna look like what? X is greater than or equal to 2 and good. Okay, and remember, we always, this might seem like, well, what if you got this backwards? What if you put in, what if you wrote this expression right here? What if you wrote instead, oops. I mean, technically, that's true, right? That's not the way we write it, though. That's incorrect in math. We don't want to write an inequality backwards like that. We always want to write them so when we have a bounded interval, it matches the segment that defines the interval, right? So you want to have the left endpoint on the left and the right endpoint on the right. So we don't want to do it that way, okay? Writing that as, using interval notation, what would that look like? My numbers are just my endpoints, right? So 2,
Brackets.
4, good, brackets, and no brackets. Okay, just real quick, I think everybody is, I don't know, just in case not everybody has seen how to do this on Moodle, I want to show you one more time.
Oh, I always try to put it back in, and it,
Oh, yeah, it like puts them on both sides.
yeah,
I
and
can't
then
do
puts
one
like
side.
a little box over another box. It's brutal.
Okay, here's how you do it. Here's how you do it. Like in Moodle, if I wanted to do the one we just did, so what was that? Here, let me do that. There we go. Oh, well, okay. So it was brackets, right, first, is that correct? So what I do is I'm going to hit the left bracket symbol. And it does that. It opens up both the left and the right. So then I remember what say it's 2 and 5. How about? If it's 2 and 5, and if I want a rounded one, then all I have to do is close it with a round one. So I'm going to hit Shift 0 and see what it does.
Oh,
It changes it. Okay? That makes sense? So I can do that the other way too. Like if I wanted to start with whoops, not those. I want to start with rounded ones. Oh my gosh, what am I doing there? There we go. So if I want to start with rounded ones and go 2, 5, if I end up now, if I close it with a square one, it changes it to a square one. Okay? So that's how you do it. On a test, if you ever had questions about how to input something, of course, ask me. I have no problem telling you how to enter something in Moodle if you have questions. That is nothing, right? I mean, that's not a math question. So. Okay, so there's the domain. Now, what about the range?
8 and 7.
Okay, so let's graph it first on the y-axis. So is there a highest value?
8.
8, and he can stand on 8, right? So we're going to get a closed circle there. What about the lowest value?
7.
Can he stand on 7?
I'm not sure.
Okay, here's the dilemma, right? He can't stand there, but he can stand there. So what's the answer? Can he stand on 7?
Yes.
He can. Yeah, there is at least one place where he can have the value y equals 7. So what kind of an endpoint am I going to put there?
Close.
Closed. Yep. Okay. And so that's my range. And so how would I write that then? Using an inequality, I'd say y is greater than or equal to
8.
7
Oh, we.
and less than or equal to the top value. It's like doing this. It's like saying, okay, I'm just going to turn the paper this way or turn my head. So
Okay.
that's going to be the left and that's going to be the right then. Okay. Okay, like that. If I want to write it using interval notation, which is what they're asking for, then I would just do square brackets, 7, 8, right?
Oh, yeah.
Okay, good. All right, what about this? Write one or more inequalities to write the interval or intervals on which the function is negative valued. So negative valued means what in terms of a graph? Say it again.
On the bottom,
On the bottom, so below the
x-axis.
x-axis, right? So where is that? Let's just graph those places. Let's graph those intervals on the x-axis. Because when we ask something like write the intervals on which something is happening, we're talking about x values. We want to know for what kind of input values is the function going to do that, right? Does that make sense? For what input values is the output going to be negative? Okay. So what's the boundary? If you were telling me, okay, an ant's going to be negative valued from here to there or something like that, where would you start? Where does the ant start to be negative valued?
4.
At
2.5. On the y. What?
Okay, we're not interested in the y, right?
Oh.
Negative valued means below the x-axis. So we want to know where is the function negative valued. Well, think what that means. Negative valued means y is less than 0, right? So that means below the x-axis.
Oh,
So where's that going to happen?
1.
So, okay, 1 is one place where it's going to start, right? Now, at 1, he's actually not negative valued, though. At 1, his value is 0, correct? I don't think she's in this class.
Okay.
So I would have to put an open circle there, right? because it's not negative valued at 1, but as the ant moves in which direction, it's definitely going to be negative valued. This way, right? Because like if I took a value, let's say we took x equals 3, for example. Well, down here, see what I'm saying? At x equals 3, the function is below the x-axis. So that works, right? But if I take a value like -1, well, that doesn't work, right? When x equals -1, the function is above the x-axis, so it's positive. So we want all the places where it's negative. Well, isn't that just going to be everything to the right of 1? So our math way of saying that would just be x is greater than 1, right?
Oh, but then you got the other side.
We got the other side too, right? So over here, where's that going to be then?
Everything to the left of -5.
To the left of -5. So our math way of saying that would be x is less than -5. And if multiple intervals exist, we're just going to put a comma in between them to be norm, right? So in Moodle, this is literally what my answer will be, right? Okay? Does that make sense? Okay. Okay, how about this? Use one or more inequalities to write the intervals in which the function is increasing. Okay, so where is this function increasing?
From
Or is it increasing anywhere?
From 2.
4. No, definitely 4.
4? So you're saying it's starting to rise over there?
No. The other way.
Right, but remember, when we're talking about the behavior of a function, we're always assuming that if we're moving in the positive direction, meaning an ant walking from left to right, where would he be walking uphill? Nowhere. Nowhere, right?
Yeah.
See what I'm saying? So what's the answer then? If there's no place where this function is increasing,
NA.
it'd be NA, right? That's the one I just fixed. Oops.
Or not an answer.
Right? The ant is only walking downhill. Is that confusing here? Because that's what this red line means. This is something we'll talk more about like in calculus, for example. But that's an asymptote, meaning the ant's going to walk down this hill, and he's always going to continue to walk downhill just a little bit and get closer and closer to that asymptote, but he never gets there. It's like this example, where I'm going to cut my distance to the door in half every second for the rest of the time. Do I ever get to the door? But am I always moving?
Yes.
Yeah, right? Weird. Always moving, but I never get to the door, ever, right? Same kind of thing here. The ant's getting, his y value is decreasing forever, but it never gets to -3. But he still is walking downhill, okay? Not uphill. Nowhere is he walking uphill, okay? Questions? Okay? Okay, that's the end of the non-graphing stuff. Now here's the graphing stuff. A lot of this is going to be pretty familiar. We went through this yesterday. So on this function here, based on the graph, what is f of 2? So we're asking, if I input an x value of 2, what's the value of the function? What's the output? What is that ordered pair?
2, 5.
Okay, so I'm inputting 2, and I'm getting back 5, right? So 5 is my answer, right? I'm inputting 2, and I get back 5 from my function. Okay, no big deal, right? How about that? Use the graph to solve the equation f of x equals -4. So we're trying to find all the x values where that happens. Well, for what x values does this graph have a y value of -4?
2.
So there's y equals,
Doesn't.
it doesn't. There's y equals -4.
No solution.
Right there, they never cross.
Did that one yesterday.
Yeah. No solution. Okay,
No solution.
how about that one? Where does f of x equal 4? So on this one, there's
Zeros.
4, right? There's the line, x equals 4, and I do get 2 intersections, there and there, right? So what are the y is 4 when x is 0 or 4. So my solutions are 0 and 4, separated with a comma. Is that an ordered pair?
Yes.
No.
Oh.
No. It's not, because I'm not asking for a point. I just want to know what are all the values for x. If there's only one, just put a number in. But if there's 4, separate all those with commas, because there's more than one, right? Here, the comma is just separating answers. It doesn't mean that that's an ordered pair. Okay?
That makes sense.
Okay, how about this? Use a graphing utility to evaluate this. Well, we'll do this one pretty quickly. We did this yesterday. All we do with this, the easiest way would just be to enter that
Desmos.
on Desmos, right? That would be line 1 on Desmos. What would line 2 be?
F
F of 1
F of 1.
equals.
And then it's going to tell me whatever the answer is, right? Okay, so there's a way to leverage the technology to do something easily and quickly. Okay, how about this? Let's look at this one. So if we want to find all the real solutions of this function, so we've got, let's go to Desmos. No, let's pull up a new one. Okay, so we're just going to put in, think what we're doing here, right? All we're going to do on this one is we want to know when does this function on the left side of the equal sign, so we'll call that f of x, when does it equal the function on the right side, right? So we'll just call that y equals 2. Okay, now later on in the class, we're going to do much the same thing, but we could have functions on both sides. I could have something like an x, some expression with x's on the left and some expression with x's on the right. What would we do? Just graph them both and find the intersections. It works even if this isn't a constant, right? So all we have to do in Desmos then is we're just going to put whatever's on the left of the equal sign is going to go, we're going to graph that in one of the rows. So line 1, let's say. So we'll do f of x, we could just call it y if we wanted to in this case, equals negative 2. Okay, how about, where do I find a square root?
In functions.
Okay, down there, right. And here it happens to be there, but what if it was a cube root? Then I'd have to go over to functions, miscellaneous, and then I could do that, and then I could put the 3 up there to make it a cube root, right? Okay, but this isn't a cube root, so we can get rid of all that stuff and just make a square root. And then inside I want to have x plus 4. If I just hit plus 1, is it going to work? If I hit plus 1, what's wrong with that?
Still in there.
It's still inside the radical. I need to hit the right arrow to get out of the radical and then do plus 1.
Oh.
Right. Okay.
Yeah.
So there you go. So there's the left side, right? Now the right side of the equation, we can just set it to be 2. So just y equals 2. And where do those cross?
They don't.
They don't cross. So what's the answer?
NA.
NA.
Yes, no
Good.
solution.
So that one's NA. Okay, let's see if I can, it's hard to do. Okay, there we go, NA. Okay, next one. How about this one? Let's just alter this a little bit so it works. We'll just edit this first line. So instead of a plus 1, we're going to get a plus 2. Inside the radical, we get x plus 5. And out front, instead of a negative 2, we get a 3. Okay, down here we have y equals 7. So those do intersect. They intersect right there, don't they? Right? And so let me take a picture of this. Oh, darn it. Okay, and so what's this tell us then? This tells us that, what's our answer going to be?
Negative 2.2.
Yeah. So we're going to round this to the nearest tenth. Good. And that just becomes negative 2.2, right? Okay, no big deal. All right, how about this guy? End behavior. Write the end behavior for the function. Well, think what this is saying now. You interpret this for me. I'm going to translate from math into English here. As x approaches infinity, the ant's moving in which direction?
Right.
To the right, yeah, because x is a horizontal value, right? So the horizontal axis is going infinitely far that way. So as the ant moves to the right forever, f of x, or y, approaches what value? 2. Yeah, if it went up like this, it would be positive infinity, right? If it went down like that, it would have been negative infinity, right? But in this case, the answer is just plain old 2. Okay, because that's where the asymptote crosses the y-axis that he's approaching. Okay? All right, how about this one? As x approaches negative infinity, stop. Does that even make sense?
No.
No. This function has an endpoint. The ant can't go to negative infinity. He can only go to negative 10, right? So this one's just plain old NA. Okay? How about this guy, average rate of change? Almost there, a couple more questions. So we're going from negative 1, when x is negative 1, the function has coordinates negative 1, negative 1,
Yep.
right? When x has positive 7, so here's positive 7.
Good.
It intersects at the point
-1.
7, negative 1, right? And so what's the average rate of change then? That's just the slope of the line connecting the endpoints, right? Well, what is that? If I calculate that slope,
0.
that's just, yeah, rise over run, right? So y2, negative 1 minus y1, negative 1 over 7 minus negative 1.
8.
So on the top I get 0, on the bottom I get 8. 0 divided by anything is
0.
0. So the answer is 0. Okay? How about this? The function below. So this is looking at extreme values. So your options here are going to be local minimum, local maximum, or neither. Which one does this function have? Local minimum, local maximum, or neither? Minimum.
Minimum.
Okay, so first answer is going to be local minimum, because it's a valley. A peak would be a maximum, right? At what point?
-1, -2.
Escape, right? No big deal. How about this one? This one's going to say, okay, so this time it's specifically saying the function has a local maximum where? A local maximum. Think what a local maximum means. Local maximum means peak, right? Local just means, so in the area of the ant when he's walking along this curve, locally speaking, so in his immediate surroundings, he's going to be on a maximum value or a peak. Where's that going to be?
-4. -2.
-2, -4, right? When the ant's standing there, he's on the top. It's not a very big one, but he's on the top of a peak, right?
Yeah.
Okay, that's a local maximum. Anything that looks like a peak is a local maximum. Anything that looks like a valley, no matter how small, is a local minimum. So the coordinates, he has a local maximum at coordinates -2, -4. Make sense? It's a wrap. That's it. Okay. Make sure you guys understand. Just make sure when I'm going to update grades today, right? You have to submit those assignments and get credit for them, right? So if you haven't done, and that may not have been clear. When you have them done, you actually have to hit submit all and finish, and then that's how they're going to go into the gradebook and Moodle. I'll be able to transfer them over. So if you got any of them complete, you haven't submitted yet, go in, submit those. I'll get them in the gradebook for you today.